Now I've angered the serial killer that put the message up there for us, so he's going to come kill us, so it was good knowing you. And the time we got, let's do some calculus. Real quick, I was really upset at myself that I got turned around, but very quickly. Yeah. We assumed that this was of this form, right?
Yeah.
Yes. So when I was having trouble about the f of a and the g of a thing, my brain was just saying it could be anything, but it couldn't be anything. Even if at a, if the limit to a is 0, it could be an open circle there, right?
Yes.
And it could be really up there. But who cares? The linear approximation I make would run through that. So that would be the value of the linear approximation today would be 0. And that's why we were able to just kill those. Alright, good. So that should have been easier than I made it. And my brain just forgot that was actually, we were assuming this. And if it was this, we talked real quick, I would just do the reciprocals of them. And then I would be back here and the whole thing still holds. Alright, so maybe. So L'Hopital's again can handle indeterminate forms all day long. Ratios, yes.
Is L'Hopital's 4.3?
L'Hopital's is 4.
Yeah.
Okay.
It's in between the first graphing and the second
So
graphing.
it's not going to quiz?
No. The quiz is,
4.3.
Up through.
yeah. And it's tomorrow.
Yes.
Good.
So it's just going to mainly deal with maxes, mins, concavity.
Yeah, it's going to, it's going to deal with critical numbers and what they mean and so forth, yeah. I'm probably not going to have enough time to make you do a whole graph, right?
You will or won't?
Probably not. I'm going to ask you, find possible inflection points, find local maxes and mins.
Will we calculate it after?
Say again?
Will we be able to calculate it?
Certainly. All right.
Just to check critical numbers.
So, what I want to do maybe is one quick example from 4.5 and then try to get into 4.7. 4.6 we don't do.
Wait, what?
Just because.
Wait, is that on the...
So with 4.5, you're just graphing the whole time, right?
Yes, so it's merging the calculus, the concavity and the inflection points and the maxes and mins and the increasing, decreasing and all that with pre-calc stuff, asymptotes and behavior and multiplicities. Yeah. So guys, hey guys, hey, how's it going? Hey. All right. So let's do this. I'm going to bypass homework questions. So too bad for you. We're going to come back. I'm going to do this first. I'm going to push the homework questions till later. Just because Jeff is really tired of racing against that thing. Alright, so let's kind of do this semi-together here. So this is going to be something from section 4.5. Alright, so it's going to be the full-blown thing. I want to know increasing, decreasing, max and min, concavity, inflection points, everything. And then we're going to graph it. So the very first thing I would ask you is horizontal asymptotes.
7 equal to 0?
No.
How do you find? How do you find it?
Take the limit
7 equal to 0.
As
infinity.
good and negative infinity, because there could actually be two separate asymptotes. We're not used to that, but we certainly could have it. So the limit. So what's it sound like I'm going to use? Because how could I rewrite this in a more useful way? Yeah, the x over is a negative power, so the e to the 2x squared. So what could I use that we just learned?
Hospital.
Yes, we could use hospital.
Take it to the hospital. Fix
Right?
it.
And then we can go get a croissant sandwich. Destroy as many languages as we can. So if I apply L'Hopital's, because is this indeterminate? Is this indeterminate? Is it indeterminate? Is it indeterminate?
Yes.
Why? What form exactly?
The ratio.
But no. What indeterminate form is it in? Infinity over infinity.
Infinidad.
So whenever you write something like that, put in parentheses, because you can't plug infinity in to something. I'm slowly trying to win you guys over on this fact. But I can't identify that as a form that it's in. It's in the form infinity over infinity. So I'm allowed to use L'Hopital's. But obviously, even without thinking L'Hopital's, which one's going to infinity faster?
E to the 2x squared.
That is certainly going to infinity faster. Therefore, it's going to outpace this, so the whole thing's going to go to 0. So I kind of know that already. But L'Hopital's is a really nice way of not having to explain it. You just do it and the numbers come out. So what's the derivative of the top? I'll do it.
1.
What's the derivative? You put this down. What's the derivative of the bottom?
ln.
No.
So
E
e.
to the 2x squared
Yeah, you get a 2x squared
or 4x.
4x.
minus 4x. I like it. Right? Chain rule. Is everybody with me?
Dang.
Yeah. And so if I put a big ass number in the bottom, the whole thing is going to go to 0. 1 over big ass is small. Alright. So well known theorem. Alright, so good. So what is the horizontal asymptote then?
0.
Y equals 0. Now if I did it for going to negative infinity, the same thing would happen. Is that true? The exact same thing. It would be 1 over big negative, which is still big negative infinity, which is still 0. Yes, ma'am.
Did you get a horizontal asymptote of infinity?
Could I? Sort of. Yes, of course you could. 'Cause
Like
what's that
that.
also known as a horizontal asymptote of infinity? It's better known as a. It's not this way. It's at a slant asymptote, right? So it's going to infinity, but in a prescribed manner. That's when you did long division, and it would follow the whatever you got when you long divided. All right, don't think about it. It's fine. I'll be all right. All right. Good question though, but look it back up. So I know the horizontal asymptote. I know this is true. I know the end behavior at the ends. It's got to be approaching the x-axis. I like it. Good. Good thing to know. Then let's go into the stuff we just recently learned. Critical numbers. First derivative of critical numbers. Just BCN. And then trying to find intervals where it's decreasing, increasing, max, min. Is everybody with me? Alright, so that should be, and now you understand why, again, I think I already said this, but I harp so much on factoring because now I'm going to set this equal to 0 to find the critical numbers, which is where things happen. So you have to be able to freaking factor to set things equal to 0 and solve, right? So what's f prime? How do I take the derivative of this?
Product rule.
Product rule. And then it's going to be minus x. I've already basically done it here, right?
Yeah.
It's just negative because it's a minus when it's up here. So minus 4x times the x that's there. Let me stop there for a second. You guys, is that cool?
Yep.
It's nice. L'Hopital's kind of did part of it for me. So the negative would come down if it was still to the negative power. And to find the critical numbers, I take that and I set it equal to 0. I also think about where is this going to be undefined. So it would have this on the bottom. Is there anywhere it would be undefined? Can that ever equal 0? No, because that's an asymptote for E itself, right? So there's nowhere where it's undefined, so I'm going to find critical numbers only where it's equal to 0. So how do I factor this?
Check out the E.
Take out the E. Take out the So I get x equals, can you guys see?
1 plus 2x, 1 minus 2x.
Well, that would be when you factor it, and then you solve. You get plus or minus 1/2. All right, how are we doing so far? So that's what's special about those points.
The critical number, so when f prime of 0 or
So that's where what might happen?
there's maximum.
Maximum. I love it. So there's possible maxes and mins, just like the second derivative of critical numbers are possible. Second derivative of critical numbers are where there's possibly inflection points. I love it. All right. Same kind of analogous process, an analogous way to interpret what's going on. All right. So how do I check this out? I can do it two different ways. I've got to eventually take the second derivative anyway. But the reason I'm going to go ahead and do the number line right now is because I want to know where it's increasing, decreasing. I want to know more than just where the max is, or min is. I need to know stuff about the slope itself. So I might as well just go ahead and do the first derivative test. So I got my negative 1/2, my positive 1/2. Christian pointed out something good. This would be a multiplicity of 1 each. So I can use that to my advantage. So if I put a 0 in, if I put a 0 in here, I get positive times positive, right?
Wrong formula.
Why?
Didn't you do the original?
No, what am I trying to get now? I'm trying to see like where it's increasing, decreasing, and that kind of stuff. I do want the slope in those locations. So if I know it's decreasing and then increasing, that is a minimum. But it's a really good point. Every time you're about to plug something into a function, stop yourself and go, all right, set the right one. Learn from Jeff, because I didn't do that the first time. All right, so now I want to know the slope. So when I plug a 0 in, is everybody cool with that? Because that's positive. That's always positive. Times positive is positive. So out here it's going to be negative, because it's got to change sign, because the multiplicity was odd. If you don't like that, plug a 1 in, plug a negative 1 in, you'll get negative eventually. It'll catch up to us. Cool. So what's happening at negative 1/2?
Yeah.
Yeah, so down to it, up from it, so it's a min here. Min at what? Something disgusting.
Plug in 1/2 to the original.
Yeah, somebody work on that right now. Just plug a negative 1/2 in there and get a decimal.
Plugging and shoving.
Plugging and shoving. I remember one semester somebody thought I was being rude, like that meant something. It's like, no, plug values in, chug the calculations. You know, don't go reporting it to my dean. I'm talking mathematically. You're the one bringing in other things. I just had to bring it up because it was funny. I was like, I can't believe it. Really? Are you honest? Really? Okay. Sure. All right.
Negative 0.30326.
For this guy?
Yeah.
So we'll make it negative 0.3. We're doing this by hand, so 1 decimal is all I need. And that's probably going to be positive 0.3, but I don't know. We'll find out. Angela's like, sure, man. I'm pretty sure it will be. Why do the work?
Yeah. Positive.
0.3?
Yeah.
Okay. So let's do this. I'm going to kind of summarize what we got, because I'm going to erase this in a bit to make some room. So what do we got so far? We got the y equals 0. We got min at negative 1/2, negative 0.3. We got a max at 1/2, positive 0.3. What else we got? Increasing, decreasing. You can just go ahead and put it over here. Where's it increasing?
Negative 1/2.
Where'd it go?
I mean,
Yeah. Increasing from
negative 1/2.
negative 1/2 to 1/2. That's where it's positive slope. And it's decreasing outside of there. All right. Okay. So I think we've sucked as much information as we can from the first derivative. All right. So let's do this. So then we're going to move on to second derivative to look at concavity, inflection points. So let me rewrite the first derivative here.
Because
So finding the second derivative.
Product rule.
Things are happening up there. Yeah, product rule. I like it. So we already did this guy's derivative. It's negative 4x e to the negative 2x squared. Is that cool? Because it would be a chain rule. Times this. So that's the derivative of the first guy. Leave the second guy alone. Plus this dude times, what's this guy's derivative?
2 times 4 is 8x to the...
Yeah, negative
8x.
8x. And if I factor this,
Pull out e to the.
I can definitely pull out e to the negative 2x squared. I mean, yeah, that's good. And I can definitely pull out... Okay, I left something out. No, I didn't. I just was a little... So yeah, I can definitely pull out negative 4x. Is that cool?
Yeah.
So then here, that whole thing came out, so I'm left with this. Plus, what am I left with over there?
2x.
2. Right?
Oh, yeah, 2. Sorry.
So I get negative 4x, e to negative 2x squared. 3 minus that. That looks right. I like it. Okay. All right, how are we there? So there's always that mixture of calculus and algebra. They're never very far from each other when you're working out a problem. So if you have any shaky algebra stuff, oh, that sucks. Right? Sucks for you. So I'm trying to make sure that's getting better. So what do I want to do with this next?
Set it equal to 0.
Yeah, so the critical numbers, the second derivative of critical numbers
Oh, okay.
are where?
Quail, they're at 0.
Good.
And then
Where?
four. The square root of 3 fourths.
Yeah. Right, 3 over 2.
Yeah, good. Plus or minus rad 3 over 2. I like it. You add that, divide by 4, take a square root. Square root of 4 is 2, so you get plus or minus rad 3 over 2. When you solve this, set that equal to 0. Yeah, everything is multiplicity 1. It's 1x. If you broke this up, it'd be 1 each. They're all multiplicity 1. So again, it's going to be changing sign everywhere. I'm going to have a slew of inflection points. So I've got negative rad 3 over 2. I've got 0, and I've got positive rad 3 over... And again, there's nowhere that this is undefined, right? You got to be real careful. Every time you take a derivative, you might introduce somewhere where it's undefined. So every time you take a derivative, you got to look for that. You don't just stop. You got to watch out.
Positive.
You guys with me? Because like a square root, when you take a derivative, all of a sudden it's on the bottom now. Oh shit! Right? So it introduced an undefined spot. So these are all 0. There's nowhere where it's undefined. So if I plug in
1.
yeah, 1.
Oh, it's on the other side. Oh wait, no, you're right. Sorry. Yeah, it's positive.
Yeah, if I plug in a 1, I get positive times...
No, well that's a
negative times negative is positive. I like it. Cool. So that's positive there. So what's going to be there?
Negative.
Negative there?
Negative.
Negative and positive. Because we know the multiplicities. Again, if you have no idea how I just did what I did, just plug in something from each region that you made, and then you get the same thing we did. So real quick, underneath here, I didn't do this for the first period. I could have done a little rough sketch, but what's the concavity here?
Up.
Up,
Down.
down,
Up.
up,
Down.
down. All right. I like it. Cool.
Unen.
So then I can say there's inflection points where?
Well, at 0.
All right. 0.
Rad 3 over 2.
What? 0 what? So it's an inflection point, right?
0.
Yeah, 0, 0. Gotta love it. 0, 0. So I'm going to go way back up to the function itself to see where the function is. I want to know what the actual point is now. So that's why I got to go back up to the original function. I like it. I like it. So you got a lot of information. You got a first derivative that tells you slopes. You got a second derivative that tells you concavities. You got a function that you started with that tells you where things are. You got to know, what do I want to know right now? So where am I going to go now? So when I plug a 0, I get 0. I've also got one at rad 3 over 2, comma, some weirdness. I love this problem. It's all about, can you use your calculator correctly?
It's so funny. In the beginning of the chapter, it says You can use your calculator, but you shouldn't. You should use calculus to graph things.
Oh, yeah, to graph it, but to get the actual value here. I'm not going to make you, good Lord. Can you calculate e to the... No, I couldn't either, so I'm not going to make you.
0.193.
So for this guy?
Yeah.
0.193, so 0.2?
Yeah.
So negative 0.2.
The other one doesn't. The other one's negative.
Negative 0.2? That's what I would guess too, but let's make sure.
Yeah.
Yes? All right.
Yeah, that's right.
Looks good? Oh, yeah, good. All right. We did the air calculator. Math people. Air guitar? No, we got air calculator. Air calculator. All right. That was weird, but I won. Concave, where's it concave up? Concave. Yeah, the infinity to this. And then from 0 to rad 3 over 2. Good Lord, Jeff. That was a neat rad. Rad 3 over 2. Or rad. And then concave down everywhere else. Because I ran out of room. Alright, so here we go. So, all of that is pretty straightforward. I don't care if the numbers get ugly. I don't care. Get calculators. I don't care. I'm going to do it by hand, so you can always round it to one place. And in fact, if we're going to do this by hand, what is rad 3 divided by 2?
Half of rad 3.
It's like 0.9 or 0.87. 0.86? All right, I can live with that. So 0.9. So everywhere we see a rad 3 over 2, it's 0.9. With me? Or you getting me? All right. All right.
Could you show us how you would sketch the graph?
Yes, we're about to do it.
Okay.
That's why I collected all that stuff, so I could have room here still at the end.
Wait.
So, let's see. Figure out my scale. So my scale is going to want to be pretty small because it looks like it doesn't get much beyond 0.9 in any direction, right? The min, the max, they go 0.5, 0.3. It looks like the largest piece of any of these points is 0.9. Right, the rad 3 over 2. You guys see that? So I got to step back and make sure that I can fit in all my important points. I got to make my scale do that. So maybe we'll do... Yeah, we'll make a 0.2, 0.4, 0.6, 0.8, 1. I like it. And the x-axis, things are happening negative at half and 0.9. So it looks like the x-axis probably the same idea, right? I want to get up to 0.9. So I can do this same thing on the x-axis, I think. Is that cool? Unless anybody has a different idea. All right. Scale went a little crazy back there, but oh, too bad for me. Okay, so here's what you want. So scale is obviously very important. We saw that yesterday, or the other, maybe it was yesterday, where it was too skinny. So I should have pulled it out a little bit more, but, live and learn. So now I'm going to mark, I'm not only going to put a point, I'm going to also tell myself what the hell it is. So as I graph, if it says min, I go, oh, I'm going to, so I don't have to, when I hit the point, I know what to do. If it says inflection point, I'll do a cup, and then I'll start the other cup there. You guys, so if you label the points, you know what to do as you get to them, right? So you don't have to kind of remember everything, you just do it as you get to it. So the min, first off, what was my function? I forgot one more thing. X e negative 2x squared. So obviously the x-intercept, one x-intercept is 0, 0. Would there be any others? Is there any other x value that would make that 0? You can never make the e part 0, so no. And so obviously that's also the y-intercept. So the intercept's not very useful. But what else is 0, 0?
the
It's
inflection.
an inflection point. Pretty good. So let's start doing our points here. There's a min at -1/2, -0.3. So right here, there's a min. There's a max at the kind of the, what do you want to call it, mirror image kind of thing over here. 1/2, 0.3. How are we doing so far? Good. All right. There's inflection point 0, 0. There's also inflection point at 0.9, 0.2. So 0.9. What was I? Yeah, I should have made my Y scale better, but screw it, Jeff. It's too bad. 0.9, 0.2. So I don't have any 0.9s in my Y. Yes, I do. No, I don't. That's freaking. That's where. See, my brain went here, and that's not really a point. Do you see the point I'm trying to? I could have made my Y-axis just pulled it out a little bit more, but I'll live with what I've done. Right? I've made my bed. I'll lie in it. -0.9, -0.2, right? For the another inflection point. -0.9, -0.2. So inflection point there and inflection point there. No inception point, thank God. It's calculus inside calculus inside. Yeah. And the train goes by and I'm like, what the hell was that? Is it a train? Okay. So we got everything up here that I figured out, right? The horizontal asymptote is here. Okay. So it's concave up from -infinity and it's increasing. Well, let's see, it's decreasing from -infinity up to -1/2, right? And the first place that I really have is here. So what do you think, since the horizontal asymptote is y = 0, how do you think it's coming, what do you think it's doing over here? So it's concave, on this side of it is concave what? Up. Right, it's concave up. So that's why you want to write those intervals so you know how to start. And then every time I hit an inflection point, I'm going to change it. Concave up, up to this point, and it is decreasing up to that point. Right? So concave up looks like that. Now, in the extreme, it could look like this. Let me try this again, Jeff. That's coming out. Concave up looks like that. And the extreme looks like this. Right?
Yeah.
All right. So what do you think it's doing back here? How do you think it's going through this? So this is a min. This is an inflection point, so it's concave down between here, right? I get this feeling like that's backwards.
Well, it is. Because
Yeah, what did you do?
root 3/2 is 0.9, and we did 1 in between 3/2 and 0. And 1 is actually on the outside. So it would have been plus, minus, so...
Oh, yeah, you're right. 1 is on the other side. Shit. Yeah. So let's see. I should have listened to you.
Well, I mean, I didn't want to say anything.
No, you're fine. I wasn't thinking right. You can always... I've got a few things on my mind. I can live with the fact that I'm not thinking about one little thing wrong. So yeah, when we did this for the concavity... And why? I want you to see why I thought this was wrong. So obviously, any of you, and me included, obviously, will make a mistake. But the reason I felt this is wrong is I know this should be kind of coming like this, so that it can approach this y-axis, right? Mm-hmm. I know this is a horizontal asymptote. And it's telling me it should be concave up, and that doesn't make any sense. How could it approach this when it wants to be concave up? So that's why I'm like, I must have made a mistake with the concavity, which I don't freak out about. I just go back and go, oh shit, I put it in the wrong place.
How do you know that the curve doesn't start like above the x-axis?
You could plug a value in,
Yeah.
because it's not impossible for it to hit the horizontal asymptote, right? You can actually intersect it, but were there any x-intercepts back here?
No.
That's the real key. The only x-intercept is here. So whatever side it starts on, it has to stay on that side, doesn't it? Because there's no way for it to come through. I used to call them doors when I taught whenever I teach pre-calc, I call the x-intercept doors. So if it starts over here and there's no door, how the hell is it going to get there? Do you see what I mean? Yeah. So it's got to start on this side. So the concavity, this is my bad, and I should have listened to you, and you feel free to speak up when I'm doing something silly. That should have been concave. My concavity was just reversed because I had 1 in the wrong place. I like it. Maybe you guys are with me.
Wait, so that's concave down?
Yeah, my concavity was just exactly reversed. So this is good, because I don't ever want to come in too prepared. I'm totally okay with making a mistake, because as a student you are going to make mistakes, and you have to know how to tell you made a mistake, and not to freak out about it, just know where to go to see what happened. So I knew the concavity was wrong based on, I know it's got to be like this. Can't be concave up there, right? And that's why I was drawing it down, because I'm like, it's got to be down. So I just go back and I go, oh, I had one in the wrong place, so all my pluses and minuses were just reversed on our concavity number line. Okay, maybe you guys are cool with that. I like it. Good.
It should be.
Yeah, so all the inflection points are still in the right place. Yeah, it's just that these two are down and the other two are up. So now this looks more like it should be. If I'm going to approach the y-axis here, it should be like that. So that's concave down. Down. And I was like, wait! That's concave down. What happens here?
Inflection, so it changes.
Yeah, so right here you can kind of make it really... Now you just start making it concave up. That should be a minimum there, Jeff. Concave up. And this is why if I would have expanded my y-axis, it would have been better, right? Okay, we could have, but I just decided not to. So that's concave up now as I go through this, and now I'm going to come here, and then that's an inflection point.
Yeah.
And my root was, well, it's supposed to be 1, plus I know I got to be over there anyway, so I'm going to go through, right? Remember that through or turn thing from pre-calc? So I'm going to go through, that's a max, and that's an inflection point, so right now I'm concave up, what's going to happen here? It makes sense, because we're going to make this dome thing here, right? So now I'm concave down, going through there. Then here I'm going to become concave up, because now I'm going to approach
the horizontal.
Yeah, so you can overemphasize your concave down to concave up change just to make sure that you actually show me you know what's going on. And if I would have made my Y scale a little bit better, I could have fit that in better. So be really good with your scale. Realize that that's a big key part of the problem, is to get a good scale. Yeah, good. That's everything for that. So that's section 4-5. All right, so you really want to do something like that. You want to collect all this stuff, put them on the graph, label them, so that as you graph, you know I'm concave up. Well, that's inflection, so I better become concave down. It's nice. You don't have to keep thinking about intervals. They really just get you started. Then the points tell you when to turn, when to change to concave down, stuff like that. Does that make sense? Yes?
I'm just confused because, like, the interval says that it's concave down from negative infinity to negative root 3 over 2. But it looks like it's going concave up.
No, so down, negative infinity to negative root 3 over 2. And then it's up from negative root 3 over 2 to 0.
Okay.
And then it's down again from 0 to root 3 over 2. Yeah, I like it. All right. So, let's try to fit in. I'm just going to jump right into a problem in 4-7. That is a statement, not a question. Because we've already done this stuff. You remember optimization problems in pre-calculus? Do you? All right, shit.
Oh, are those... So, yeah.
So everybody got this
So you
here?
have a square and it's like... That's right?
It's like a rectangle.
There's like a rectangle next to a water and...
Sure. Yeah, you got the house and you want to build a pen for your pet.
For your pigs, yeah.
Oh, yeah. This stuff is fun.
Gotta keep them penned in, or else, you got the elves playing out
Are
here.
those guys like the cones?
A little nice
Maybe so you can tell.
right?
Yeah.
So real quick, and the perimeter of this is, I don't know, it's going to work nice. So let's make it 40. So when I teach this to my pre-calc class, we're going to do the exact same thing here. So if you have me for pre-calc, you're good. So here they always tell you something, and then they ask you something. So here I'm going to ask you to maximize the area. I want to give my orc a lot of area to roam, because I want orcs, happy orcs is better than not happy. He's going to bust through the house. I need the orcs in the house. Sitcom, man. Oh yeah. All right.
Honey, he keeps taking my wedding ring.
So write an expression for what they tell you, and use that in what they ask you. So what's the expression, of course, for what they tell me?
2x equals
No.
2x plus
2y.
equals 40.
Why is there only one Y? Because this is the house, right? I've already got a wall there. Or it's next to a river or something, and the orc doesn't like to swim. So you don't have to fence that side. I don't know. Remember those problems? I know you do.
You have to implicitly differentiate it.
No. Well, we'll get there.
You could.
You'll see. You
Yeah.
could.
Yeah.
You could, but it's easier. We'll see.
Oh, you just
So this is pre-calc, by the way. We're not going to do any calculus, believe it or not, for this problem. I just want to remind you how this works. What's the formula for they ask me? Yes, so it's xy. And I want to maximize that, right? So there's too many variables in there. So of course I use what they tell me. Y is 40 minus 2x, and I plug that in. So I get area is 40x minus 2x squared. Who remembers the shortcut for finding the... And where is the maximum occurring, of course, on something like this? What is this? What's it look like if I graphed it? Parabola. Upside down parabola, even better. That's why it's got a max, right? How do I find the max quickly?
Tangent.
Back in pre-calculus.
Oh, okay.
Oh, pre-calc, Jeff. Come on, man.
Yeah.
Come on. X equals... Now watch. Stay with me now. Here's some calculus for you. Ready? Ready, kids? So, use calculus. How would I find this guy's maximum? I would...
Yeah, take the F prime.
So then I'd be 2ax plus
B.
b, and I said it equals 0, and what do you get when you solve for x? What do you get? You get freaking negative b over 2. So back in pre-calc, you had to use completing the square, or something to get here. Look at the calculus eats it. Spits it out. Right? Alright, so that's the shortcut. That's the calculus proof of the shortcut, which is nice. So what are we going to do? Like you said, why would I do that when it's calculus? And we're not going to get quadratic functions all the time. We're going to get who knows what. So calculus can handle multi-curves. Pre-calc, you could only do one turning point. Pre-calc, yeah, I got to find the vertex. But now we can have... right? We can have... Who knows? Who cares? So let's do a real calculus word problem, and then it's going to be time to go. Yeah.
For real.
That was not real.
Yeah.
That was not real, because you could do it. It was imaginary. Alright, let's see. Ooh, I like this one. A box with a square base. And an open top. This is a classic. Must have a volume of 32,000 cubic centimeters. So you can have a short box that's really wide, or you can have a really tall box that's really skinny, or something in the middle. So that's why there's multiple ways, there's an infinite number of ways to have this happen. But I want, of course, the way that's going to minimize the amount of material I use. Oh, shit. Find the dimensions.
The perfect box.
To minimize the material used. So, material used. What does that relate to physically about this box? Surface area. I love it. So let's draw the box. Let's draw it. That was just beyond dead. I think it erased what some of that was already up. So let's see. Let's not go crazy here. So it's got an open top. That's important because I don't need to use material for the top. So it's not going to factor into the surface area. So that open top actually totally is required to know how to use that. The base is square, so what can I call these? And what am I going to call this?
Why?
Is it a cube? No, it just said it has a square base.
H.
Ache. Or use Y.
Or L.
Or L. You could use freaking happy face. P. That you can't use that. Sorry. That's the one letter in the universe you can't use. All right. So remember what I said. They're going to tell you something. Write the equation for what they told you. They're going to ask you something. Write the equation for what they ask you, and then see how you can use them together. And then whatever we end up with, we're going to attack it with calculus. Right? Kill it with fire. So, what do they tell me? Volume. They tell me the volume has got to be 32,000. What's the formula for the volume of this thing?
The volume is X.
Good. X squared equals 32,000. Jeff, don't go crazy. They tell me this, and what do they ask me?
Find the dimension. Minimize.
Minimize the material, which we had to interpret to mean surface area has to be minimized. So what's the surface area of this? Whoa. No. Yeah, surface area would be 1x squared, right? Because there's no, it's open. So an x squared for the base plus 4 xh's. You stop there for a second. Is that, you guys see where all that came from? There's a bottom. What's the area of the bottom? X squared. And there's 4 sides. The area is xh.
How do you know that you're using surface area?
So I've got to know, when they say minimize the material used, I can get a square footage of whatever to make this thing, right? So the material I'm using is the area, the surface area. The inside's empty, so there's no material inside. Does that make sense?
Yeah.
Coolness.
Sweet.
So what's wrong with this is there's too many variables. Now you could do implicit, you could have, but why? You've got, you know this, so what can I use from this to help me with that?
Oh, 32,000 over H equals... Oh, wait, no. Well, you
Better, solve for H.
Yeah.
Right? So you get H equals... I didn't mean it to be anything. I don't want to quell any enthusiasm.
Yeah.
And now you can write the surface area a little bit better. It's x squared plus 4x times that. So one of the x's is going to cancel, right?
Yeah, so 32,000.
And 4 times that.
4 times 2 is...
Good. 128,000.
12. Yeah.
Is that cool?
Yeah.
So it's 4x times that. One of the x's cancels, and then 4 times that is there. And then what do I do with this? To find the minimum,
You have to take the derivative.
take the derivative,
So you can
find the
tan.
critical number. Yeah, I like it.
Oh, but it was because it was x squared, and then you were multiplying. See the 4x? The x is killed.
So right here is be 4x times this. One of the x's cancels, and the 4 times that is 128,000.
Okay.
Yeah. So the derivative would be
2x.
2x minus, because it's on the bottom, right?
Yeah.
X is -1, so -1 comes down. 128,000 over x squared. So how do you find the critical numbers for that?
Yeah, and then you could factor it.
Now all this takes is algebra, and of course this is where some of my students die. They just die on this. Let me take this Jenny's beautiful writing away before you guys get jealous. Come back to my chicken scratch.
So
How do I solve that?
128,000 x negative x.
No,
Or x to the negative 2.
Add it over,
And then you divide. Oh. Oh yeah, you can do that.
multiply x squared up, divide by 2, right?
Yeah.
I mean, come on now, you know how to solve equations, don't we?
Yeah.
Every now and again. Only on Thursdays, Jeff. And today ain't Thursday.
It's 4,000?
No.
400.
Yeah.
440.
Cubed is 64 is 4. The cubed of 1,000 is 10.
40.
40. That's crazy, came out nice. You almost don't trust it when it comes out nice now, right? You're like, I must have made a mistake. The 40 is too nice. So this side, that's 40 centimeters, 40 centimeters, and the H would be what? H equals 32,000 over
1600.
Yeah. So bam, bam, 20.
Yep.
And how do you check yourself? Well, 20 times 40 times 40 better be 32,000. And it is. Yeah. Isn't that crazy?
I like it better than the pre-calc one.
Well, yeah, of course. Well, but pre-calc was pretty easy because you just had to use this, and all the problems had to come out to be parabolas. Now they can come out to be anything, but calculus doesn't care what they are. It'll just attack you. You're a what? Really? I don't care. And you get here, you just have to be able to do the algebra here, and you'll be golden. Right?
4/7.
That's 4/7. Just reminding you guys of what's going on. I still haven't gotten a room because nobody reminded me, and I remembered right before class, oh yeah, I never need to get a room. I desperately need to do that today so that there's actually a room left for us. Monday is the test, so tomorrow I'll have the practice test. No, test will go to 4.8. So tomorrow we're going to focus on section 4.8.
And then we'll review that be on Thursday.
The review for the test Thursday. For the next test.
When are we going to find